how do you folks feel about number 9?
Not really that confident.
Okay, so we're going to take about, so today what we're doing is we finished up the absolute graph, value graph. We finished that part, so none of that. And we're just going to review for exam 1, that's it. In class due today is the linear models homework. So do you have your linear models homework? Go ahead and pull that out. I'll be collecting that in just a minute. If you have any past homeworks, I'm happy to take those too as well, so pass those in as well. Tonight you have linear models due tonight. Sunday you have those inverses of linear functions due. Again, this is those 8 problems that I yanked out of the Unit 2 ones because we hadn't really gone over how to find an inverse yet. So that's practice, you're finding inverses. And then the exam will be on Monday. What we'll do is we'll prep for the first half. And then we'll prep for an hour. So the actual exam will start at 12. It is a 50-minute exam, 50 minutes.
Is this any questions?
Yep.
I mean,
Yes. It'll be basically that. It'll be a variation of that, but it'll be super, super similar to that. And yeah, so that's.
question.
All right, but we're going to do it twice, right? We're going to do it once in this class, and then you're going to do this previous one, the practice exam, you're going to do that at home. And again, you're going to check your answers online, because on Canvas, all the answers to that, not the one I just gave you, because I just made that last night, but the one that I gave you last week, all those answers are online on Canvas. You go to Unit 1 study, or Module 1 exam, your study guides, it's all in there. The answers and the study guides are there.
Is how to do the question there, or just the final answer?
No. I do all the steps.
Oh, okay. Good.
Yeah, I'm not going to see the answer.
Good.
I'll show you all the steps.
Okay.
Okay. All right, so let's go ahead and take a vote. So problem number 1, you can vote for 5, that way we can kind of keep it down to something reasonable. Or vote for all the ones you feel like you really don't know how to do. Okay, who wants number 1?
I just want 1D.
1B?
1D.
1Z? D. 1D? Okay, is that what okay, so we have 2 votes for that, plus 1, plus 3 votes for 1D. Okay, how about number 2? Everyone feels good about number 2? Number 3? No votes for number 3? Number 4? Number 4? 1 vote for number 4. Number 5? No votes for 5. 6? Okay, there's 5 votes for number 6. Number 7?
Sure.
2 votes for number 7. 3 votes for number 7. Number 8? 2 votes, 3 votes for number 4 votes for number 8. Number 9? 2 votes for number 9. 3 votes for number 9. Okay, so we'll do number 6 first, followed by, maybe we'll do 6, 7, 8, 9, and then we'll come back. Well, we can hit, yeah, we'll hit number 1 quickly, I suppose. We could do that. We'll just do 1, let's see, there's number 1D. So we'll do, we can do 1 very, very fast. And then come back and pick up, that will include D as well. Okay. All right, so number 1, given the f of x equals 5 over 3x minus 1/3, find f of 0. So you're gonna rewrite this the exact same way you would, right? Y equals 5 over 3. Everywhere you see x, you're just gonna put a big parentheses. And inside there, for this one, you're gonna put 0 inside of there. Right, so if I put 0 inside of there, I'll get y equals 5/3 times 0 minus 1/3. Well, anything times 0 is 0, so that goes away. So you're just left with 1/3. Right, so f of 0,
Negative 1/3.
Yeah,
oh, I'm sorry. Thank you. Thank you, sir. Thank you also for catching it right away. All right, so remember, this, f of 2, that's my y. 2 is my x. All right, so now if I did f of 2, it's the same thing, only I'd be putting 2 into this space here, right? So if we did that, we would end up with y equals 5/3 times 2 minus 1/3. And you just pop that into your calculator, and maybe you'll get a decimal, that's fine. But you should kind of be comfortable, hopefully, with the idea that 2 is the same thing as 2 over 1, and you can multiply fractions. So how do you multiply a fraction? You multiply the numerators, and you multiply the denominators. So 5 times 2 is 10. You know what, I'll do the extra step. 5 times 2 over 3 times 1 minus 1/3. So then you end up with 10 over 3 minus 1/3. And it's important for you guys to remember, this is how many there are. The top is how many there are. The bottom is what it is. It's a third. So think of it like a third of a pizza. This is 10 thirds of a pizza. So 10 people get a third, I have 10 thirds of a pizza. Think of a like the Costco giant slices that are a sixth of a pizza. Think of a double one of those. I have 10 of those kind of double slices. Minus one of them. I'm going to eat one of them. How many do I have left? I have 10 of them. I eat one of them. I'm left with how many? 9 of them. 9 what's? 9/3. Good? So the bottom tells you what it is. This tells you how many.
Is this the final answer?
Nope.
Oh, okay.
I just said the final answer. What's the final answer? I have 10 of them. I eat one of them. How many do I have left?
Oh, yeah, it's 9 over.
If I have 9, right?
Yeah.
Over 3.
9 what's? Thirds.
Oh, thirds? That 3 minus 3 is 0.
No. Okay. This tells you what it is. It's a third of a pizza.
I don't
Okay,
understand.
hold
Why
on.
would you minus the top, but you don't minus the bottom.
Because the bottom tells you what it is. It's a third. So here I have these are all thirds of a pizza. I have 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. 10 thirds of a pizza. Is everybody understanding what this is? Do you agree this is 10 thirds of a pizza?
Okay.
Is that agreement or not?
Yes.
This is a third of a pizza, there's 10 of them. I subtract one of them, 1/3. I subtract this one. Now how many thirds do I have left? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 thirds left. How many pizzas is that, incidentally?
3 pizzas.
3. So yeah, 9 thirds reduces to 3.
Yeah, I mean, I get it when you say it that way, but I just still don't understand why you're not, I mean, it's everything else you're doing the bottom one.
Because this tells you what it is.
Yeah,
This tells you it's a third.
yeah.
So think of a third as an object. This says what it is. This tells you how many you have. So this is what you have. Draw a picture out every time. Then it'll be clear. This says what you, this is how many. This is what size it is.
So what if
So-
the numbers were different, if it wasn't a 3 on the bottom?
Okay, so I'm not gonna give you that in class.
Oh, okay. Then we would,
Then you would not, that would be a math 55 question. That's not a math 50 question. So this tells you what it is. This tells you how many there are. This, it's sort of like a, kind of like, do you do tools? Do you work with tools at all?
a little bit.
So think about it as saying, I have 10 third wrenches, 1/3 size wrenches. Okay, so, or you 13 millimeter, I don't know, whatever, you want to use. I have 10 of them. I lose one of them, or give one of them away. How many do I have left? I have 9 of them. What are they? 1/3 wrenches, or whatever. I mean, that's not really a term. I mean, there's a one of those, but say there was,
Yeah.
right? So that's the same concept. This says what it is, whether it's a third of a pizza, or a quarter of a pizza, or a sixth of a pizza. And then this tells you how many of them we have. That's how those things work. That's exactly how those work. Right? Because 10/3 is this. Okay, but if you want to talk about more, we can talk about later. But I want to make sure that the class want to honor what people want to do in the class and make sure we meet everybody's needs. So let's take a look at an equation that will translate f of x 4 up. So f of x is this. Y equals, or f of x equals 5/3 x minus 1/3. I need to go up 4. Is up 4 on the inside or the outside? Up, down, up, down. So when I translate up, down, is that on the inside of the function or on the outside of the function?
Outside.
Outside of the function. So that means on the outside of the function, at the end, I'm going to tack on. Up 4 means what? Plus 4. Good. Now, if it's a whole number, which on the exam I believe it will be a whole number, then I expect you to combine these. If it's a fraction like that, you can leave it alone. So everyone hear me? If that's a whole number and this is a fraction, right? This is over 1, that's a third. I don't expect you to combine them if you're adding them. But I am 98% certain that on your exam these will both be whole numbers. Everybody good with that part? So then you would just, if this is -1 plus 4, you combine like terms.
Where are you getting 5/3 and you get 1/3 from?
From the function,
Oh, so you're referring back to the top, okay.
yeah, f of x. What's f of x?
Okay. Okay.
Right, f of x, this is f of x. For this whole problem, this is f of x.
Oh, okay.
That, at the very top, is f of x.
Okay.
Plus.
What?
Never mind.
All right, good. All right, so the next one we wanted to go over was number 6. Now, for horses, eats oats at a constant rate. In the beginning of the month, there are 80 pounds of oats. 6 days later, there are 56 pounds of oats. And after 11 days, there are 36 pounds of oats. Okay, this is a word problem. Everybody confident with that part? If you get a word problem, you need to figure out your 2 variables. Because in this class, you're going to have an x and a y. Just that's how this class rolls. So figure out what 2 things vary And the one you can control or time should be your x. So everybody should write down here. So next to it or somewhere, write down x represents, or is, if you want to write is, that's fine. X is blank, y is blank. Or maybe represents, if you're not sure what is that's going to confuse you, then write down represents. represents, y represents. And maybe on your note card, if you have a blank sheet of paper, you should write on there somewhere, word problem, figure out what x and y represent. Right, it should be your first step. So everybody take 15 seconds, figure out what two things vary in this problem, and which one should be x and which one should be y. Changes.
Pounds of oat.
Pounds of oats. Great. Alex, give me another thing that changes.
The days, so like the time.
Yeah. The number of days? Yep. All right, so then, Jenna, which one is x?
Days.
Days, because that's my time. Remember, x or it's either the thing you control or it's time. So then y would be, Natalia, y would be, what's the other thing that changes?
The pounds?
Yeah, pounds of oats. Great. Should I even do pounds? Pounds of oats. Great. All right, good. So that means that I need, so everyone write down the formula that I need to find here. Is it going to be y equals x squared, y equals 1 over x, y equals what? What kind of formula am I looking for? It's a constant rate, so it should be y equals anyone?
mx plus b?
Yep, y equals mx plus b. Everybody comfortable realizing that? This exam is, the only functions I'm giving you guys in this exam are going to be linear functions. So y equals mx plus b is the only word problem you're going to get this whole exam. Good, but you need to have that in your notes. So somewhere in your notes, if you're making a list of things that should be on your little note card, you get one index card of notes. That's something you probably want to have on there. Did everybody hear that? Okay, so maybe you should have a piece of paper or something where you can be writing some of the stuff down and what you should have on the note, on your note card. Okay. All right, so then, what do I need to find? In order to have y equals mx plus b, I need to find what two things?
M.
M? Yeah, m is 1, and what was the other one?
Y-intercept?
The my y-intercept, my b. Right, I just need to find those two things, m and b, and I'm golden, I have it. Y equals 3x minus 4, whatever it is, right? I need to figure out what m and b are. M is my, what's m?
Slope.
My slope,
Rise over run.
also known as my, it's also known as my rate of change. And my rise over run. My B is my y-intercept, also known as my starting amount or my initial amount. So these are all things that you probably want to have written down somewhere on your note card. Right? I would definitely, if I was learning it, I would totally be writing down y equals mx plus b, m is my slope, comma, rise over run, comma, rate of change. Right? So then I can figure out how to grab it and figure it out. And then I'd write b is my y-intercept, comma, my initial amount. Right? You want to have that information at your fingertips. Okay, good. All right, so then it says, let's construct a graph. So why don't you folks conduct a graph? What's the first thing we do when we make a graph? Well, I would do this normally, right? That's the first thing I do when I make a graph. Everyone agree? But here's the thing, if it's a word problem,
Start from zero.
yeah, you only care about the positive stuff.
Yeah.
So I'm going to, here's my graph, I would erase these two parts because I only care about the positive, because you're not going to have negative oats or negative days. Okay, so which one's my x? Figure out where my x goes. Remember the first one, the first line you draw is your x, and then we add with the y going up and down, so label what x is along here, what does it stand for? And you know, maybe go, let's see, I go up to, what does x stand for? What's my x again?
Days.
Days. So I definitely have zero, start at 0 days. And then maybe, let's see, I talked about 11 days. So maybe I might go to like 15 or 20. I might give myself room to have 15. So I might go 0, 5, 10, 15. That seems reasonable enough. All right, you got to cover the numbers that we give you. This is days. And then, what's my y again? Ryan, what's my y? Ryan?
The pounds of oats.
Mm-hmm. So pounds of oats. And what do I have to start at 0. The y should always start at 0, but what's the most it has? It's like, what's the most that it has out of the, so find all your pounds of oats. Everyone find and circle all your pounds of oats in here. Circle all of them. How many pounds of oats, like the number and the pounds of oats, right? The whole, right, like here, I'll give you an example. Here's the first one. 80 pounds of oats, that's one. Find the rest of them. There should be 3. All right, David, give me one of them. David, what's one of them?
Oh, 50 pounds of oats.
56? Yeah.
56,
Yeah.
sorry.
Kelly, what's another one?
36.
36. Eric, what's the last one?
80.
Great. So 80 is my biggest one. That means I need to make sure I at least go up to 80. So maybe I go 10, 20, 30, 40, 50, 60, 70, 80. And just label at least a couple. Label 0, 80, and maybe one in between. That's reasonable enough. You can work off of that. Okay, and then graph it. So everybody graph the 3 points. Oh, the 3 points. Oh. All right, so then what? So the pounds of oats are my y's. I need to find the x's that go with them. So everybody figure out, I should have 3 points here. I should have something, comma, 80. Something, comma, 56. Something, comma, 36. Is everybody realizing why? Because these are my y's. 80 is my y, 56 is another y, 36 is another y. Everybody find the x's that match up with each of these. Find the x's that match up with them. And then probably give me one.
6 and 56.
6 and 56. Jenna, give me another one.
11 and 36.
11 and 36, perfect. Fox, give me the last one.
80 and 0 and
0 and 80, right? Because at the beginning, that's 0, right? That means 0 days. Good. Perfect. So then graph your 3 points. Remember, first I go to the elevator, then I go up and down. So 0, I don't go anywhere, and I go up to 80. 6, I go right here, up to 56. 11, up to 36. So it makes kind of a line, more or less. And depending on how good your drawing skills are, they might be less of a line or more of a line, but they should fall in a line. Like mine's off a little bit here, right? So technically that dot should have been down a little bit lower, you know, just work with it. You know it's a line. Okay, good. So when you think about the scale for the axes, think about what's the minimum and maximum. And pretty much 0 should be your minimum. But think about the maximum you want to go to. And make sure you cover that. Like, I could have just gone just to 11 and that would have been fine. I need to make sure I at least went from 0 to 11, at least went from 0 to 80 this way. So this, you know, cover your axes. Now if your year, yeah. That should be fine. Okay, so the next step, find the slope, connecting 2 points of your graph. So you can either do this and say, okay, what's my rise and what's my run? All right, so do whichever one is more comfortable for you. This is 0, 80. This is 6, 56. This is 11, 36. You can either do that and figure out, okay, what's my rise and my run as I go along here. Or you can do, if you're more comfortable, so, okay, let me give you that one. So if I were doing that one, I would say, okay, to do this, I went down. My rise is negative. I went down from 80 to 56. So I went down 24, negative 24. And then my run is 0 to 6, 6. Or you can just take 2 points, 0, 80, and 6, 56. And do that whole subtraction thing. But again, I would start from the back one, the furthest back, and that's the one that's on top. 56 minus 80, and then the 6 minus 0 on the bottom. So remember the top one is the furthest back. You start with the y's at the very back, and that's the one that's on top. 56 minus 80 on top, and then on the bottom would be 6 minus 0. You always start from the back one. So then I'd end up with n equals 56 minus 80. Well, why am I doing it? You guys do it. Get your slope. And then interpret the slope in the context of the problem. In other words, what does it have to do with, I don't know, kittens in Alaska, or the number of hot dogs sold at a fair? What is this rate? Tell me what that rate represents.